The Earth is alive, just like the human body. It has many different systems in it, similar to how the human body has systems like the digestive and muscular systems. Earthquakes, volcanoes, and different kinds of weather show us that the Earth grows and changes over time, just like we do. The study of geology, or earth science, helps us understand how our planet works and evolves. The Earth is made up of several layers, each with its own unique features. The outer layer, where we live, is called the crust. It's like the skin of the Earth, thin and solid. Below the crust is the mantle, which is much thicker and made of rock which can flow very slowly. Deeper still is the outer core, which is liquid metal, and at the very center is the inner core, a solid ball of metal. These layers work together to keep the Earth functioning. But just as our bodies can have sudden movements or changes, so too can the Earth. For example, earthquakes are an intense shakings of the Earth's surface. The Earth's crust is made up of huge areas called plates which move around very slowly on the mantle. Sometimes these plates get stuck. Pressure builds up, and when they finally move, the energy they release causes the ground to shake. This movement of the Earth's plates not only causes earthquakes but also plays a role in the formation of volcanoes. When plates move, they can create spaces where magma from the mantle can rise up to the surface. When magma reaches the surface, it erupts as lava, forming a volcano. Volcanoes are a clear sign that the Earth is not just a static rock, but a dynamic, living planet with processes happening deep within it. Volcanoes, earthquakes, and plate tectonics are all part of Earth's life and evolution. Geologists believe that at first the Earth was a hot, molten ball, but over billions of years it cooled and formed a solid crust. Water appeared, and eventually life began to develop. Paleontology, the study of fossils, helps us understand Earth's history by providing a glimpse into the lives of plants and animals which lived long ago. By studying fossils, scientists can learn about the different types of creatures that once roamed the Earth, how they looked, and how they lived. Meanwhile, the study of rocks, minerals, gems, and diamonds reveals the treasures hidden within Earth's crust. Rocks are the building blocks of the Earth's crust and come in many different shapes, sizes, and colors. Some rocks are made from cooled magma, while others are formed from layers of sand and mud. Some rocks have changed from one type to another due to heat and pressure. Inside rocks, we can find minerals, which are natural substances, each with a specific structure. Some minerals are very valuable, like gems and diamonds. Gems and diamonds are beautiful and often used in jewelry. Diamonds are extremely hard and are also used in tools. Fossils, rocks, and minerals are the Earth's way of preserving its history. The Earth is made up of three main layers: the crust, the mantle, and the core. These layers interact with each other to create the dynamic processes that shape our world. The Earth's crust is the outermost layer of our planet, like the shell of an egg. It is the thinnest of the three layers. There are two main types of crust: continental and oceanic. Continental crust makes up the continents or landmass. It is thicker and less dense than oceanic crust. This crust is mainly made of granite, a rock that is light-colored and rich in minerals like quartz. The continental crust can be between 30 and 70 kilometers thick and is often much older than the oceanic crust. Oceanic crust lies beneath the oceans. It is thinner and denser than continental crust. The oceanic crust is mostly basalt, a dark-colored rock rich in iron and magnesium. It is typically around 5 to 10 kilometers thick and is younger than continental crust because it is constantly being formed and destroyed at mid-ocean ridges and subduction zones. Beneath the crust lies the mantle, a layer that extends much deeper into the Earth and connects to the core. The mantle's movement and properties influence the surface features we see, such as mountains and earthquakes. It extends from about 5 to 2,900 kilometers below the surface. The mantle is made up of rocks which are mostly silicates, including minerals like olivine, garnet, and pyroxene. It also contains magnesium, oxide, and other elements like iron, aluminum, and potassium. The mantle is divided into several layers: the upper mantle, the transition zone, and the lower mantle. The upper mantle includes the lithosphere, which is solid and firm, and the asthenosphere, which is softer and partially melted. Between the upper and lower mantle lies the transition zone, a region where the mantle undergoes significant changes in mineral composition and density. This zone extends from about 410 to 660 kilometers below the surface. Below the transition zone is the D double prime zone, a complex and less understood part of the lower mantle. This region, extending from about 660 to 2,900 kilometers deep, is characterized by variations in temperature and pressure which influence mantle convection and the movement of tectonic plates. Below the mantle is the core, the deepest layer of Earth, where extreme heat and pressure give rise to a different set of conditions and materials that influence the planet's magnetic field. The core is the innermost layer of Earth and is composed mostly of iron and nickel. It is divided into two parts, the outer core and the inner core. The outer core is liquid and lies below the mantle. It is about 2,900 to 5,150 kilometers deep. The movement of the liquid iron and nickel in the outer core creates Earth's magnetic field. The inner core is solid and is located at the very center of the Earth, about 5,150 to 6,350 kilometers deep. Despite the extreme temperatures, the inner core remains solid due to the immense pressure. Together, these three layers, the crust, mantle, and core, form the structure of our planet and shape the Earth as we know it. Life on Earth would be impossible without the atmosphere. The atmosphere is like a blanket around the Earth, protecting us from dangerous rays from the sun and from the cold of outer space. It contains water vapor which forms the clouds that bring rain. It also contains the air that we breathe, which is made up of the gases oxygen, nitrogen, and carbon dioxide. Earth's atmosphere is divided into several layers: the troposphere, stratosphere, mesosphere, thermosphere, and the exosphere. The troposphere reaches about 11 kilometers above the ground. Most weather occurs in the troposphere. The stratosphere extends from 11 to 50 kilometers up. Airplanes fly here to avoid the winds and weather lower down. Within the stratosphere, there is a thin layer of the gas ozone. Ozone absorbs powerful rays from the sun and is crucial for our survival. However, pollution and the use of certain chemicals are very much damaging the ozone layer. By the way, please subscribe to this channel for more videos about space and science. The mesosphere extends from 50 to 80 kilometers. Most meteors burn up in this layer, causing shooting stars. The thermosphere extends from 80 to 480 kilometers and doesn't contain much air. The exosphere is the final layer with almost no air at all. Satellites orbit the Earth in the exosphere. The Earth is over 4 billion years old and is constantly changing. One example of a process going on within the Earth are earthquakes. Earthquakes are mainly caused by movement in the Earth's outer layer called the crust. The crust is thought to be made up of large, solid rock pieces known as tectonic plates which are always moving. Some plates move apart from one another, some slide past each other, and some dive beneath other plates. Most earthquakes occur at plate boundaries. The plates are always slowly moving, but sometimes they get stuck at their edges due to friction. Pressure builds up. When the pressure on the edge of the plate becomes greater than the friction, there is an earthquake. This releases energy in the form of waves which travel through the Earth's crust and cause the shaking that we feel. Earthquakes are very common. They happen all the time. Most are too small to notice, but some can cause significant destruction. The point where the earthquake occurs is called the epicenter. In powerful earthquakes, the shaking can be felt thousands of miles from the epicenter. Earthquakes which occur along plate boundaries in the ocean can cause tsunamis. Tsunamis are huge waves which can cause great destruction when they reach land. One of the most active earthquake zones is the Ring of Fire, which circles the Pacific Ocean. This zone includes the mountainous western coast of North and South America and parts of Asia. Scientists use seismographs to study earthquakes. They record the shock waves produced during a quake. The strength of an earthquake can be measured in different ways. The most common is the Richter scale. and measures the energy released by an earthquake. The Mercalli scale calculates the damage caused. The movement of tectonic plates also helps to explain continental drift, the movement of the continents. Continental drift leads to the formation and breakup of continents. A supercontinent called Pangaea began breaking apart around 270 million years ago. As Pangaea split, the pieces gradually drifted to form the continents and landmasses we know today. A volcano is an opening in the Earth's surface where hot gases and melted rock from deep inside the Earth come out. During a volcanic eruption, hot, melted rock called magma escapes through a vent or opening in Earth's surface. This material can either flow slowly out of a crack in the ground or burst suddenly into the air. When magma reaches the surface, it is called lava. As the lava cools down, it hardens into rock. Although volcanic eruption can cause a lot of damage, they also help create new landforms. There are currently over 1,500 active volcanoes in the world. Earth's outer layer or crust is made up of large rocky plates that move slowly. They are called tectonic plates. Most volcanoes are found along the edges where these plates meet. Some volcanoes are formed where two plates pull apart. This allows molten rock to rise up between them. By the way, please like and subscribe for more videos about the Earth. Volcanic eruptions create new landforms. For example, the island of Iceland formed when volcanic eruptions along the mid-Atlantic ridge piled up lava and ash over a long period of time. The two most common types of landforms made by volcanoes are stratovolcanoes and shield volcanoes. Stratovolcanoes are cone-shaped mountains with steep sides and a wide base. They are made up of layers of hardened lava and ash from many eruptions over millions of years. Mount Fuji in Japan is a stratovolcano. Shield volcanoes, on the other hand, are dome-shaped mountains created by flowing lava. They are not as steep as stratovolcanoes but can be very large. Some shield volcanoes erupt under the sea and grow tall enough to form islands like the volcanoes in Hawaii. Volcanoes also have some benefits. The ash from volcanoes, known as andesol, is good for farming because it makes the soil rich. Additionally, the heat released by volcanoes, known as geothermal energy, is a source of power that is used in many countries to heat homes and produce electricity. Paleontology is a study of ancient life on Earth through fossils. Fossils are the preserved remains or traces of living things from the past. They are important for understanding the history of the Earth. By studying where fossils are found in different rock layers, scientists can figure out the order of events that have shaped the evolution of our planet. This includes things like the movement of continents, changes in sea levels, and the effects of big events like asteroid impacts and volcanic eruptions. Fossils can be dinosaur bones, the imprints of leaves, or even the footprints of ancient animals. These remains are usually found in layers of rock that have built up over millions of years. As layers of sand, mud, and other materials pile up, they trap and preserve the remains of plants and animals. The process of fossil formation needs special conditions. When a plant or animal dies, its remains need to be buried quickly in order to keep it from being eaten by other animals or broken down by the weather. This usually happens in places where sand or mud is being deposited, like riverbeds, lakes, or ocean floors. Over time, more layers build up on top, and the pressure turns these layers into rock. The remains inside may slowly change into stone as minerals replace the original material. This is how most fossils are formed. In some cases, the remains of an organism may completely break down, leaving an empty space in the rock in the shape of the organism. If the space later fills with minerals, it creates a cast fossil, which is like a copy of the original organism. Fossils can also form in other ways, like when small animals or insects get trapped in tree resin, which hardens into amber and preserves them. The most famous examples of fossils are dinosaur bones. These animals have fascinated people for over 100 years. Dinosaurs lived during the Mesozoic era, which lasted from about 250 to 65 million years ago. Their fossils have been found all over the world, showing a wide variety of species. Studying dinosaur fossils has taught us a lot about the biology, behavior, and extinction of these ancient creatures. Fossils are fascinating. Please subscribe for more videos. Thank you for watching.